Let's practice determining the intermolecular forces between the particles of the following substances. First, we have H2. H2 is composed of two atoms of hydrogen. So both are nonmetals. So this one is obviously a covalent bond. So let's identify whether this covalent bond or whether this molecule is polar or nonpolar. So the electronegativity of hydrogen, that's 2.1, and the same thing for this atom. So here they have the same strength. So this one is a nonpolar molecule. And let's say there is another H2 molecule here. So the same thing, it's also a nonpolar molecule. So there's no charge here. So here the intermolecular force is a dispersion force. So again, here there are electrons moving around this molecule. And let's say at a particular moment, all of these electrons are on this right side. At this moment, this side becomes slightly negative and this side becomes slightly positive. And the same thing for this molecule here. Again, the electrons are constantly moving at a particular time. Let's assume all the electrons are here. So this side becomes slightly negative and this side becomes slightly positive. Here we have two different charges, and here they can be attracted to each other. So we call this force, this attractive force, as a dispersion force. So again, dispersion force occurs between a nonpolar and another nonpolar molecule. Let's take HF. HF is composed of hydrogen bonded to fluorine. So here, hydrogen is a nonmetal, the same thing for fluorine. So this one is a covalent compound. In covalent compound, they are sharing electrons. Now let's identify whether it's a polar or a nonpolar molecule. So hydrogen, the electronegativity is 2.1. And the electronegativity of fluorine, that is over here, fluorine, that's 4.0. So the electronegativity of fluorine is 4.0. Obviously, it's not equal sharing. So here, fluorine becomes partially negative and hydrogen becomes partially positive. So it's obvious that HF is this one is a polar molecule. And let's say we have another polar molecule here, HF. Again, H partially positive and F is partially negative. Here, partially positive, then here we have partially negative. They can be attracted to each other. Okay, now this one is what type of intermolecular force? Well, again, these are polar molecules, so it can be a dipole. But on this case, remember that on this case, the hydrogen, this one is attached to a fluorine. So this one is a stronger type of dipole-dipole force. This one is this type of interaction is a hydrogen bonding. Hydrogen bonding. So hydrogen bonding occurs between a polar and another polar molecule, but on this case, it must contain a hydrogen that is attached to a fluorine. Again, that's hydrogen attached to fluorine or oxygen or nitrogen. So this one is a hydrogen bonding. Let's take magnesium oxide or MgO. It's composed of magnesium and oxygen. Magnesium is a metal and oxygen is non-metal. Therefore, this one is again metal plus non-metal. Therefore, this one is an ionic bonding. In ionic bonding, so here the magnesium will transfer electrons to oxygen. After the transfer of electrons, oxygen becomes negative because it receives the electron, and magnesium becomes positive. And let's say we have another MgO here, that's magnesium positive and oxygen is negative. And here we have different charges, negative and positive, so they can be attracted to each other. Now this one, it occurs between an ionic compound and another ionic compound. Therefore, this one is an ion-ion interaction. Okay, next we have HCl. HCl, that's H and Cl. Hydrogen is non-metal, the same thing for chlorine. It's also non-metal, therefore this one is covalent bonding. The electronegativity of hydrogen 2.1 and the electronegativity of chlorine, that is 3.0. Okay, 3.0. So this one is unequal sharing, so Cl becomes partially negative and hydrogen becomes partially positive. Therefore, HCl is a polar molecule. Another HCl molecule here, partially positive, partially negative. Also a polar molecule. Here we have partially negative, positive, partially negative. They'll be attracted to each other. What type of interaction is this? So this one is the same with this. It's a polar and polar. But on this case, the hydrogen is not attached to the fluorine, oxygen, or nitrogen. So this one is just a dipole force.